Hello guys, today we are going to go over reporting category 2, which is about key characteristics of linear functions, slope, y-intercept, x-intercepts, zeros, those different things, correlation, coefficients, things like that, and just translating them from mathematical terms and just understanding how to explain them in normal English terms. The first one to look at is the correlation coefficient. This is where we put in our calculators, go to stat, edit, put in our points, and then go to calc and do a line regression, and we see our slope and our y-intercept. Now the thing that we didn't spend a lot of time on, which will help you not only with line regressions but with quadratic regressions and exponential regressions, is that correlation coefficient. Alright, a 1 means the closer to 1 or negative 1 is a 1. Positive 1 is a strong positive correlation, a negative 1 is a strong negative correlation. It's kind of they're going in the opposite directions. If you're looking at a graph, the dot's going to be all over the place. So if you look at this one, it has a pretty strong correlation because they're all semi-close to the line. But in order for that correlation coefficient to come on, you have to go to mode and turn your stat diagnostics on. Alright, by default it's off, so you just go over, press enter. Now it isn't completely necessary to turn it on because I'm sure a lot of us are going to forget, but if you can remember to turn your stat diagnostics on and you have a question about correlation, it'll be easy to answer. Now if you have a graph, you can kind of read the correlation. Like I said, this one is pretty strong, probably around 0.7, 0.8ish, so that's pretty strong. But it will be even more accurate if you can put the points in and turn your stat diagnostics on. Parent functions are the graphs without any transformation. So this is linear, y equals x, and it goes through the origin, so it doesn't shift up or down. It has a 1-to-1 slope. You may also see it as f of x equals x. Same thing with quadratic, f of x equals x squared, and f of x equals ab to the x. Alright, so the parent functions, again, just the graph with no transformations. It's just y equals x, y equals 1x, slope is 1, y-intercept is 0. And to find that slope, we should know that it's the change in y over change in x, rise over run. So it doesn't matter if you're given a table, given 2 points, you have the actual graph, given an equation, you should be able to find the slope, especially when given 2 points. When you're given 2 points, say we need to find the equation, one of the first things we have to do is to find the slope. So to find the slope, you label your x and y. X and y. Now it doesn't matter which one is 2 and which one is 1. You just have to subtract them in the same order. Alright, so I can do -2 minus 6, this one minus this one. So then I have to do this one minus this one, -2 minus 2. And I get a -8 over -4, which is a +2. Now I'm going to do it the other way also, so you see it doesn't matter. So you have 6 minus -2 and 2 minus -2. We know that negative turns to a plus, so you have 8 over 4, and that is 2. So it doesn't matter which one is the first or second point, it just matters the order in which you do it in. So if I do this point, this y first, at the bottom I have to do this x first. If I do this one first, then I have to do that one first. So that's the only thing that matters on there. Alright, so when we're interpreting slope, you first find your slope, and your top, of course, is the change in y, change in x. So it's happening, there are y things happening x amount of times. So if you look here, it's hard to see here, the height of the candle in inches, the number of hours it's burning. So the height of the candle per hour. So this is the height remaining after this many hours of the candle burning. All right, real simple. So you just put it in terms, you just say y per x, and then kind of make it make more sense. Put it in terms. All right, x and y intercepts. Y-intercept is usually where it starts. So like the same example from the last problem, last page. At the beginning, the candle was 10 feet high. All right, no time has passed. 10 feet. So the candle started at 10 inches. So I said feet, 10 inches. Candle started at 10 inches. Or the candle was 10 inches before it started burning. However you want to word it. But knowing that 0, 10, after no time has passed, the candle was 10 inches tall. Alright, so also the x-intercept, same thing. What does it mean? This is 10 hours, 0 inches. So it took 10 hours for the candle to burn completely. So after 10 hours, 10 hours, oh, it already says it right there. So the candle was done burning after 10 hours. Alright, because there wasn't nothing left. It's easy, but just being able to interpret that, the slope, the y-intercept, those x-intercept, those different things. Now, if you're in decimals, use your calculator. So we have a table. We can use our calculator to interpret that table, or to find the equation for that table. And so, like I told you at the beginning, go to stat, edit. I'm going to clear these out. To clear, you just go to the top, press clear, enter, put your x values in the y1. So negative 7.5, negative 3.5, negative 1, 2, 3.5. Put your y values in the y2, L2. 12, 0, negative 7.5. Boom. Then I don't think I turned my stat diagnostics on, so I'm gonna go check real quick. And I did, so good. So stat, calc, go down to line regression, and then calculate. Then we get all of our information here. So this is a strong negative correlation. Our R value is -1. Y-intercept is -10.5. Slope is -3, so it is A. Alright, you can do this by hand, but why? The calculator can do all the work for you. But if you did need to find the slope, just find 2 points on here, for example. Change in Y, change in X. So the change in Y, this is going down, what's that, 9? And this is going up 3. So change in Y is 9, change in X is 3, and that is in fact -3, which is the slope we got right there. Alright, so just an example of how you would find your slope when given a table. Now, also let's look at this table some more. We should know that this is the x-intercept because it's where y is 0. So the x-intercept is where y is 0, y-intercept is where x is 0. So you can find a lot of information just from looking at the table. Alright, and the last thing are transformations and function notation. So this is something we struggled with a little bit. So let's look at it really quickly. So if I'm looking at this graph, when the transformation is happening just to x, so it's x minus plus something times something divided by something, it's going to change it on the horizontal axis, left and right. Alright, so this, and when it's happening, when it's adding or subtracting, it's going to do the opposite of the sign. So this graph is going to move 4 units to the right because it has a minus. So it's going to move to the opposite when it's happening to the whole function. So remember, f of x is a function. Alright, so if I'm adding 1 to this function, my function is 2x plus 3. So I'm going to take this function and shift it up 1 unit. So my new equation will actually be 2x plus 3 plus 1, which is 2x plus 4. So it's going to change that y-intercept from 3 to 4. We're multiplying. Here again, we're multiplying the whole function. So it's going to stretch it vertically, or it's going to change it vertically up and down. Alright, it's either going to pull it, make it steeper, or it's going to get flatter. So if I'm changing the slope of a line and I'm making it bigger, it's going to get steeper. But as it gets smaller, it's going to get flatter. Our vertical stretch, vertical compression is getting flatter. So I'm multiplying this whole equation by 5. So that'd be 10x plus 15. And the difference here with it's hard to see a horizontal stretch with the linear equation, but still, again, we're just multiplying the x value by 6. So your equation would be 2 times negative 6x, close the parentheses because it's just happening to x, plus 3. Now because we can distribute that 2, it's going to end up being negative 12x plus 3. Notice that the y-intercept doesn't change. Alright, it's just all the x values are going to change, so it's going to make it steeper this way because it's negative. Boop, boop, boop. Oh, so this goes here. Alright, so that is reporting category 2. Slightly longer, but if you have any questions, please let me know.